Alright, this is problem number 6 on the purple worksheet. So in this situation, I'm going to show you the diagram. It is a little confusing if you read the problem, so I set it up so you can look at it this way. We have a playground that's on a flat roof. It's 6 meters above the street below. Then there's a wall of the building that's 7 meters high all the way around. So that 7 goes from the ground up to the top of the wall. And then there's a 1 meter difference between the top of the wall and the roof. So that's what the 7 and the 1 represent. And then we know that it is 24 meters away. That's where the person is. So they are going to return the ball to the kids with an angle of 53 degrees. And it's going to take 2.2 seconds to reach the point on the wall. So we're trying to find the speed it was kicked, the amount of clearance it has over the wall, and the distance. So step 1, we're given the distance horizontally as well as the time horizontally, so we should immediately just find the horizontal velocity. It makes the most sense. So taking 24 and dividing it by 2.2 is going to give us an initial x velocity of 10.91 meters per second. Now the question is asking for the overall speed that the ball was kicked, so that's going to be the hypotenuse of our component triangle. So we know that we have our angle of 53 degrees, and then we have our v initial, which is what we're looking for. VOX is what we just found. So knowing what we know, it's going to be cosine because it's the adjacent and the hypotenuse. So cosine of theta is going to be our adjacent over hypotenuse, which is VOX over V initial. Since we're looking for the V initial, we're going to change the position of the V initial and the cosine. We're going to flip them. So we're going to get VOX divided by the cosine of theta, and that is going to give us our initial V unit of velocity. So 10.91 divided by the cosine of 53, that will give us a value for V initial of 18.13 meters per second, which is the answer for A. So that's going to tell us the overall speed that the ball is kicked. So now from here, we need to make some other choices about the other two questions. So we're trying to figure out the amount of clearance the ball has over the wall, and then the distance from the wall to the point where it was on the roof. So essentially, we're trying to find clearance. So we're trying to figure out where we peak. So at that time, do we peak prior to the wall or at the wall? So there's a couple different ways to approach this. So I'm going to do it this version, but then I'll discuss when. So instead of where do we peak, because that's a normal convention to say where, we actually mean when, meaning at what time is our peak happening. So to find that, I'm going to use that VOX that we just calculated to find our V initial in the y direction. So I'm going to take that 10.91, I'm going to multiply it by the tangent of the angle. So that's going to give us our VOY value. And I'm using VOX instead of the V initial just because if I already messed it up, I don't want to do like a double whammy and get them super incorrect. So 14.49 is what I get for my V initial Y. So that is the velocity that the person returning the ball gives the ball in the vertical direction. So at this point, we need to figure out what we do with that information. So the peak velocity is going to end up being 0. That's what happens. So V final Y is 0. The initial Y we just found, gravity we have. So we're trying to figure out what that time value is. So we're going to compare that to the time it takes to reach the wall, just because we're trying to figure out if it peaks before or after. So we're going to figure out that the time up is 1.477 seconds. So it's going to take that much time to reach the peak, and then it's going to fall for the rest of the time. So I'm going to figure out what that delta y is, which is going to tell us how high that peak value is. So using the fact that at the peak we have a velocity of 0, we have different options. I'm going to rearrange the v final y squared equation. Because I know my velocities and I know gravity, I'm just going to do that one instead of using the time. So calculating would cancel out the v final y because it's at the peak, so it's 0. So that's going to give us the negative of 14.49 squared divided by 2 times gravity. And that's going to give us a peak height of 10.701 meters. So that tells us that at its highest point, the ball will be 10.701 meters in the air. So as far as the diagram goes, what we have is the ball starting on the ground, and then we have that building. So we're going to peak at a point higher than the wall, which means that we will then continue through the air for the remainder of the time and come to a point above the wall, We don't know what that point is, and that's ultimately what we're trying to find, because the question's asking for the amount of clearance. So we can use the time x, which is equal to the sum of up plus down, and that's going to tell us how much time it takes to fall. So the 2.2 seconds that it's totally in the air is made up of the 1.477 up plus the rest, which is down. So it's going to be falling from its highest point for 0.72 seconds. So this time is going to give us the ability to calculate how far down it actually falls. So we're going to figure out what that distance is. So we can use the free fall equation, and that's going to be our best option because we don't know our final velocity at that point. We could use another equation, but we would have to find v final first, so that's not the most efficient. So how far do we fall? Let's say that delta y is going to be equal to 1/2 gt squared. We're going to use our gravity. We've got our time. Plug that in, and then what we're going to get is that 2.564 meters negative. So we're going to be falling that amount from the peak. So we start out diagram-wise looking at what we have. We peak at that 10, and that's above the wall. So the peak minus what we just fell down is going to be the height when we reach the wall. So taking that 10.7 that we calculated and subtracting the 2.5, we will get our actual elevation at the wall position. We get that when we reach the wall, the ball is going to be 8.137 meters in the air. So this means that we definitely are going to clear the wall. And this value, which is a little tricky, is above the ground. This is not above the wall height, because that can be a little confusing. So this is above the ground. So the wall height was 7, and we have a height at that point of the 8.137 meters, which means that our clearance is just the difference between those values. So we get that we have cleared the wall by 1.137 meters, and that is the answer to B. Now, alternatively, we have another option, and that option would be just to use the overall time we took to get to the wall, which is what we've done in class. Now, admittedly, that is a little quicker, so we could do that option. This one, I think, really shows the conceptual aspect of the fact that you're going up and then you're falling back down. So either one is correct, and it should yield the same answer. So moving on to C, we're going to find the distance from the wall to the point where the ball lands on the roof. Alright, so when it lands on the roof, we have some choices, and the best way that I think to find it is to figure out where it needs to fall. So when we reach that 2.2 seconds, we have already fallen to a height of 8.137 meters. So we need to fall another 2.137 meters to reach the actual level of the playground, to get to that 6-meter high value, which is the floor of the roof. Now, unfortunately, you can't just go from that value. We need to actively do something about the fact that it has a speed at that point. So the trap here is to just use the free fall equation and do 1/2 gt squared, because you know the distance that it falls and you want to find a time to go from there. However, you are going to actually need to figure out the speed at that point. So you can use the time that the object was falling to find the velocity it has at the wall, and then use that velocity when you do your calculations. So v final y is equal to v initial y plus gravity times time. So your v final y is technically what we're looking for, and that's going to be 0 plus negative 9.81 multiplied by the time it fell, which was 0.732. So that is going to give us a v final y, which is going to be our velocity when we are at the wall position, and that is going to be 7.18 meters per second, and it's negative because it's down. So that velocity will be the initial velocity for that 2.137 distance that we're talking about. So we need to figure out how much time it takes to fall that distance, as well as what is our actual delta x from there. So delta y, we have our value already, and that's our 2.137. V initial y is what we just found, even though we technically found v final. So that's negative 7.18. Your delta y is negative. We don't know time, so we're going to be solving for that. We have 1/2 gravity, which is negative 9.81, multiplied again by time squared. Now, already by looking at that, it's not something you want to do because we can't easily factor that, and we can't eliminate anything. So we have to use the quadratic equation for that. So I'm not going to show you how to use that because you should know at this point. So I'll just show you what the roots are that we end up with. So 0.25 or 0.172. So with that, we can get rid of the negative 1.72 because a negative time doesn't exist. And it makes sense that if we only have to fall a little bit, we're not going to have that much time. So to find our delta x, we use our velocity in the x direction multiplied by our time. We had found our velocity prior, which was 10.91. We just found our time. So multiplying those two together, we will get our delta x distance, which is how far past the wall we went, of 2.73 meters. So again, that is past the wall position. So total from kick, we went a distance of 26.73 meters, but we're just trying to figure out where it lands on the roof with respect to the wall.